Swedish firm Saab has today submitted its proposal of 12 new Gripen C fighter aircraft to Croatia. Representatives of the Swedish Defence Material Administration (FMV) and the Swedish Embassy in Croatia submitted the government-to-government proposal of 12 new Gripen C fighter aircraft to the Croatian authorities. Parallel to Sweden's proposal, Saab is offering a tailor-made strategic cooperation package that will boost the Croatian defense industry, and benefit Croatian security by building a long-term partnership with strategic sectors. Gripen C is a modern and proven multi-role fighter that uses the latest technology and performs an extensive range of air-to-air, air-to-ground and reconnaissance missions. The aircraft is in operational service with the air forces of Sweden, Hungary, the Czech Republic, South Africa and Thailand. Gripen fighters of the Czech and Hungarian air forces participate regularly in NATO operations and exercises, proving the fighters' full NATO interoperability. Recently, the company offered Gripen combat jet with new decoy missile system for Finland's HX fighter procurement project. The Gripen is a multi-role fighter aircraft, intended as a lightweight and agile aerial platform with advanced, highly adaptable avionics. It has canard control surfaces that contribute a positive lift force at all speeds, while the generous lift from the delta wing compensates for the rear stabilizer, producing negative lift at high speeds, increasing induced drag. Being intentionally unstable and employing digital fly-by-wire flight controls to maintain stability removes many flight restrictions, improves maneuverability, and reduces drag. The Gripen also has good short takeoff performance, being able to maintain a high sink rate and strengthened to withstand the stresses of short landings. A pair of air brakes are located on the sides of the rear fuselage. The canards also angle downward to act as air brakes and decrease landing distance. It is capable of flying at a 70 to 80 degrees angle of attack. To enable the Gripen to have a long service life, roughly 50 years, Saab designed it to have low maintenance requirements. Major systems such as the RM-12 engine and PS-05, a radar are modular to reduce operating cost and increase reliability. The Gripen was designed to be flexible, so that newly developed sensors, computers, and armaments could be integrated as technology advances. The aircraft was estimated to be roughly 67% sourced from Swedish or European suppliers and 33% from the US. One key aspect of the Gripen program that Saab have been keen to emphasize has been technology transfer agreements and industrial partnerships with export customers. The Gripen is typically customized to customer requirements, enabling the routine inclusion of local suppliers in the manufacturing and support processes. All of the Gripen's avionics are fully integrated using 5mm STD1553B digital data buses, in what is described as sensor fusion. The total integration of the avionics makes the Gripen a programmable aircraft, allowing software updates to be introduced over time to increase performance and allow for additional operational roles and equipment. The ADA programming language was adopted for the Gripen, and is used for the primary flight controls on the final prototypes from 1996 onwards and all subsequent production aircraft. The Gripen's software is continuously being improved to add new capabilities, as compared to the preceding Viggen, which was updated only in an 18-month schedule. Much of the data generated from the onboard sensors and by cockpit activity is digitally recorded throughout the length of an entire mission. This information can be replayed in the cockpit or easily extracted for detailed post-mission analysis using a data transfer unit that can also be used to insert mission data to the aircraft. The Gripen, like the Viggen, was designed to operate as one component of a networked national defense system, which allows for automatic exchange of information in real time between Gripen aircraft and ground facilities. According to Saab, the Gripen features the world's most highly developed data link. The Gripen's Turnav tactical navigation system combines information from multiple onboard systems such as the air data computer, radar altimeter, and GPS to continuously calculate the Gripen's location. The Gripen entered service using the PS-05, a pulse Doppler X-band multi-mode radar, developed by Ericsson and GEC Marconi, which is based on the latter's advanced Blue Vixen radar for the Sea Harrier that also served as the basis for the Eurofighter's Captor radar. The all-weather radar is capable of locating and identifying targets 120 kilometers (74 miles) away, and automatically tracking multiple targets in the upper and lower spheres, on the ground and sea or in the air. It can guide several beyond visual range air-to-air missiles to multiple targets simultaneously. Saab stated the PS-05A is able to handle all types of air defense, air-to-surface, and reconnaissance missions, 98, and is developing a Mark IV upgrade to it. The Mark IV version has a 150% increase in high-altitude air-to-air detection ranges, detection and tracking of smaller targets at current ranges, 140% improvement in air-to-air mode at low altitude, and full integration of modern weapons such as the AIM-120C7 AMRAAM, AIM-9X Sidewinder, and MBDA Meteor missiles. The future Gripen EF will use a new active electronically scanned array AESA radar, Raven ES-05, based on the Vixen AESA radar family from Celix S. Among other improvements, the new radar is to be capable of scanning over a greatly increased field of view and improved range. In addition, the new Gripen integrates the Skyward G infrared search and track (IRST) sensor, which is capable of passively detecting thermal emissions from air and ground targets in the aircraft's vicinity. The sensors of the Gripen E are claimed to be able to detect low radar cross-section (RCS) targets at beyond visual range. Targets are tracked by a best sensor dominates system, either by onboard sensors or through the transmitter auxiliary unit (TAU) data link function of the radar. The Gripen is compatible with a number of different armaments, beyond the aircraft's single 27mm Mauser Bk-27 cannon, omitted on the two-seat variants, including air-to-air missiles such as the AIM-9 Sidewinder, air-to-ground missiles such as the AGM-65 Maverick, and anti-ship missiles such as the RBS-15. In 2010, the Swedish Air Force's Gripen fleet completed the MS-19 upgrade process, enabling compatibility with a range of weapons, including the long-range MBDA Meteor missile, the short-range Iris-T missile and the GBU-49 laser-guided bomb. In flight, the Gripen is typically capable of carrying up to 6,500 kilograms, 14,330 pounds, of assorted armaments and equipment. Equipment includes external sensor pods for reconnaissance and target designation, such as Rafael's Lightning Targeting Pod, Saab's Modular Reconnaissance Pod System, or Thales' Digital Joint Reconnaissance Pod. The Gripen has an advanced and integrated electronic warfare suite, capable of operating in an undetectable passive mode or to actively jam hostile radar. A missile approach warning system passively detects and tracks incoming missiles. In November 2013, it was announced that Saab will be the first to offer the Bright Cloud expendable active jammer developed by Celix S. In June 2014, the Enhanced Survivability Technology Modular Self-Protection Pod, a defensive missile countermeasure pod, performed its first flight on the Gripen. Saab describes the Gripen as a swing-roll aircraft, stating that it is capable of instantly switching between roles at the push of a button. The human-machine interface changes when switching between roles, being optimized by the computer in response to new situations and threats. The Gripen is also equipped to use a number of different communication standards and systems, including Saturn Secure Radio, Link 16, Rover, and satellite uplinks. Equipment for performing long-range missions, such as an aerial refueling probe and onboard oxygen generation system (OBOGS), was integrated upon the Gripen C.